We have a formula: pressure equal force upon area. That means when area is more, in that case pressure will be less, and when area is less, in that case pressure will be more. Okay, so what is pressure? Pressure is a force acting a unit area of the object. Okay, and Newton per meter square is a standard unit of pressure. So we have a question numerical. A brick is 0.3 meter long, 0.1 meter wide, and its weight 24 Newton, and it is laying on the ground. So find the pressure exerted by the brick on the ground. Okay, so here you have see in the questions, we have in the question force is given here 24 Newton. Okay, and we find out the pressure. So we know the formula of pressure: pressure equal force upon area, right? So force equal 24 Newton. Now what is area? So here you can see a brick is 0.3 meter long and 0.1 meter wide. That means brick is a rectangular in shape, right? And the area of rectangle is L into B. Okay, so firstly we find the area of the brick. So area of a brick, because a brick is a rectangular in shape, so the area of brick is L into B. So here L equals 0.3 and B equals 0.1. That here is 0.3 into 0.1, multiply 0.03 meter square is the area. Okay, then pressure equal F upon A. F equal 24 Newton and A equal, we just get the area of the brick 0.03. So now here 24 upon 0.03. So 800 Newton per meter square is our answer. Means 800 Newton per meter square pressure exerted by the brick on the ground. First talk about liquid. Okay, so I will just tell you about a very simple experiment which will prove that liquid exert pressure on the wall of the container. Okay, so what do we do for this purpose? You take a glass tube with a side opening rubber balloon like this. Now you fill this glass in liquid, maybe water. Sometimes when you increasing the amount of water in this container, you see that the pressure exerted on the walls of the container. Because of this pressure, this balloon to get start inflated. So balloon is getting blown due to the presence of this pressure by the liquids which is present inside the container. So the here liquid exerted the pressure on the walls of the container, and it can be seen in this inflated balloon. So here you can see when the liquid exerted pressure on the walls of this container, the balloon inflated, right? So in this case you have seen here, this experiment shows that liquid exerted pressure on the walls of the container. You have seen here, when we increasing the amount of water here, the balloon get inflated. Because why this happens? Because the liquid exerted pressure on the walls of this container, and that's why the balloons get inflated. So this experiment shows that the liquid exerted pressure on the walls of the container. There is an activity which is related to the atmospheric pressure. Okay, I just explain this activity, and do this activity at your home. Okay, so you take a glass which is filled water. Okay, and then you take a piece of thick card and keep this card on the glass of this water and press the card hard. Press the card so there is no air in the glass. Okay, and after that keep the card in position with one hand and invert the glass. You have to invert this glass like this. Now you withdraw your hand support. So what you observe here? You will see the pieces of card. You can see here the card does not fall through the glass. Glass is full of the water, right? And this water is exert pressure on the card in the downward direction. But this card does not fall. Why? Why the card does not fall? Because the atmospheric pressure act on the card in the upward direction and hold the card in place the upward direction. Okay, so the upward direction, the atmospheric pressure acting, which is greater than the downward pressure of the water on the card. So this shows that atmospheric pressure